This is the MiG-21, the most produced jet fighter in history and one of the longest-serving fighters in aviation. It was designed back in the 1950s as a Mach 2 frontline fighter. It became iconic for its distinctive delta wings, circular nose intake, and incredible agility. The MiG-21 embodied the Soviet air defense approach for taking on heavier Western aircraft using hit and run tactics. In this video, we're going to be taking a deep dive into the MiG-21 F-13, the first major export variant of this aircraft, and the first to be equipped with air-to-air missiles, to explore how this legendary aircraft changed air combat tactics. My name is David Webb, and this is Blue Paw Print. The MiG-21 F-13 airframe was built for agility at supersonic speeds. It measured 44 feet 1.9 inches long and stood 13 feet 5.4 inches tall, weighing 12,882 pounds when empty. Its delta wings had an area of 247.6 square feet and a wingspan of 23 feet 5.7 inches. Its main counterpart, the American F-4D Phantom II, was much bigger, at just over 58 foot long, and it was more than twice as heavy, at a shade under 29,000 pounds. The fuselage was all metal, made from an alloy of aluminium and magnesium, with steel in the places that needed extra strength. Its semi-monocoque design struck a balance between strength and weight. The fuselage had an oval cross-section and was divided into two main sections. The forward section housed the cockpit, wings, fuel tanks, and the main landing gear, while the aft contained the engine, tail assembly, and exhaust nozzle. These two sections were divided by a disassembly joint at frame number 28 to allow engine maintenance and removal access. The front of the aircraft was recognizable due to its circular nose air intake and adjustable nose cone. Right below the intake lip was a long pitot tube that measured the aircraft's airspeed, angle of attack, and yaw. The MiG-21's delta wings were perhaps its most distinctive feature. They swept back from the fuselage at an angle of 33 degrees, out to cropped tips. Structurally, each wing was built around a main spar and two secondary spars running along the leading and trailing edges. This design, along with the MiG-21's short fuselage, made it highly responsive in rolls and allowed pilots to change directions quickly. It also helped the plane pull high angles of attack, which was a key advantage for ambush tactics. Each wing had one hardpoint for external stores and housed two internal fuel cells located in front of and behind the landing gear wells. The MiG-21's quick roll rates were aided by its relatively small control surfaces, primarily the ailerons. The ailerons had a maximum deflection of 20 degrees in both directions and were operated by actuator rods powered by a booster hydraulic system. If necessary, the hydraulic boost could be switched off, although this made aileron control more difficult. The flaps located between the ailerons and the wing roots acted as secondary control surfaces. When taking off and landing, the flaps would extend to 24.5 degrees, boosting the wing's curvature and helping the aircraft lift off safely at speeds as low as 211 miles an hour. Two small wing fences were added to the wings to help manage airflow and boost aerodynamic stability. The tail section's control surfaces consisted of a vertical fin with a rudder, a set of stabilators, and a ventral fin positioned on the bottom of the fuselage. The MiG-21 F-13 had fully moving horizontal stabilators that made the controls smoother at lower speeds and allowed for a rapid climb, crucial for getting out of tricky situations during combat. The control system featured an ARU-3V module that changed how much force you needed to move the control stick, depending on how fast the plane was going and its altitude. When the plane was going slow, the controls felt lighter and easier to use. But when it was flying fast or at low altitudes, the controls got heavier to help avoid oversteering and keep the aircraft safe from excessive stress. The plane had 3 hydraulically operated air brakes. The front set of 2 air brakes were located on both sides of the lower fuselage, while the rear air brake was positioned between the fuselage pylon and the ventral fin. Additionally, the MiG-21 was fitted with a circular-shaped braking parachute housed in a heat-insulated compartment on the bottom left side of the fuselage, just in front of the ventral fin. The MiG-21 F-13 was a remarkably fast aircraft for its time. It could reach a maximum speed of 1,351 miles an hour at an altitude of 42,650 feet, the equivalent to around Mach 2.05. At sea level, its top speed was around 745 miles an hour. These high speeds were made possible by the twin-axial Tumansky R-11F 300 jet engine. The engine system consisted of a 6-stage compressor with 10 separate flame tubes in the combustion chamber, a 2-stage turbine, an afterburner chamber, and an adjustable exhaust nozzle. The engine had a diameter of just over 2.5 feet, measured just over 15 feet in length, and weighed 2,606 pounds. At full power, the engine operated at 11,150 RPM and delivered a maximum thrust of 8,598 pound-force under standard conditions without using the afterburner. The aircraft's thrust could be increased by engaging an additional component integrated into the engine called the afterburner. The afterburner consisted of radially arranged fuel injectors positioned just behind the engine turbines. It worked by injecting fuel directly into the afterburner chamber, where it ignited upon contact with the hot exhaust gases, producing significant extra thrust. With the afterburner at minimum, the MiG-21 F-13 engine produced 10,803 pound-force, while at maximum output, it generated 12,677 pound-force, nearly a 50% increase over the standard thrust. The afterburner gave a significant boost in thrust, but it also used significantly more fuel, so it was mostly used for takeoff, combat, and supersonic flight situations where additional thrust was essential. Thanks to this powerful engine and the MiG-21 being relatively light, it could accelerate and climb quickly. This made it easier for pilots to take sharp turns and recover energy quickly during dogfights. The MiG-21 F-13 fuel system consisted of 7 internal fuselage fuel tanks and 4 tanks within the wings, giving a total capacity of 652 gallons. This was 5 times less than the capacity of the American F-4, which could be loaded up with 3,335 US gallons of fuel. Depending on altitude and the power setting, typical flight duration ranged from 45 minutes to an hour. But if you use the afterburner at low altitude, the aircraft could use up all its fuel in under 20 minutes. To extend the operational range, the aircraft could be equipped with an external drop tank mounted on a central fuselage pylon. An essential component in achieving maximum engine output was the air intake system, arguably the most distinctive feature of the MiG-21's design. The aircraft's primary air intake was regulated by an adjustable cone. The nose cone was hydraulically operated and had 3 positions. Fully retracted was used for speeds up to Mach 1.5. The middle position was for speeds between Mach 1.5 and 1.9, while fully extended was used for speeds above Mach 1.9. The aircraft was also equipped with 3 sets of auxiliary air intakes designed to prevent engine stall, provide additional airflow during takeoff for extra thrust, and cool down various components in the rear of the fuselage. Opposite the nose cone was an exhaust nozzle. Its adjustable design helped control the exhaust gas flow, making thrust and fuel efficiency better during different flight phases. The nozzle worked automatically. When the engine was idling or running at low RPM, the nozzle would be wide open. As the throttle increased, the nozzle contracted, reaching its smallest size at about 65 to 68% RPM. If you turned on the afterburner, the nozzle opened back up to its maximum diameter. In the event of automatic control failure, the pilot could adjust the nozzle manually, but only for two settings, fully open or fully closed. The MiG-21 F-13 weapon system consisted of a radio rangefinder, the SRD-5MK, one NR-30 cannon, and two K-13 R-3S heat-seeking missiles, which could be replaced with weapons intended for ground attacks. The MiG-21 F-13 did not have a radar in the modern sense. Instead, it had a range-only SRD-5 radar system built into the nose that couldn't search or track. There wasn't a dedicated display in the cockpit for it. It only worked with the ASP-5ND optical gun sight for aiming both the cannon and the missiles. The single NR-30 cannon was mounted on the lower right side of the front fuselage.